Today we're writing more Rust. We're diving back into 16-bit virtual machine. Now, I haven't actually streamed any of this on Twitch yet, so maybe let's jump over and have a look at what this virtual machine does at the moment. Where we left things off last time. We have a couple of little test programs. Let's look at the branch program. This is kind of a fun one. Let's actually edit it rather than just listing that the file exists, right? A little simple virtual machine. We have an assembly format that is quite verbose. The instruction names are long. I'll talk about why that is in a second, but we can test things. We can see what the value in a register is. We can branch based on this test. We can load values and manipulate values, and we have a signal instruction, which is our way of interacting with the outside world. In this case, signal. This signal is set up as the kind of kill the machine, the halt and catch fire signal. Okay, how do I look in there? Am I framed? I'm framed. Okay, this is okay. I might give myself a little bit more headroom. Let's do this. You don't need to see quite as much of my torso. I know it's a very nice torso, but you'll just have to make do. Okay, so we got this working. We can assemble this. This just dumps out a bunch of binary garbage to the terminal. We have to pipe this out to a file. Excellent, and now we can run this virtual machine and it'll do everything, and hopefully we can see that the right things are loaded into memory. I think they are. I think we left things working at the end of last stream. Okay, so this is good. We have a little virtual machine. We have things that run on the virtual machine. Last time we were adding more instructions, we were fleshing things out a bit more, and I started to try and write some programs, and I realized very quickly that working with an assembler that is so basic, it's just a little bit too limiting. So all our assembler does at the moment is look at our list of ops, right? We have all of a bunch of macro magic that generates kind of the glue code the assembler uses based on these, which is why we use the actual instruction names as defined in the instruction, in the instruction enum, as the actual instruction in the assembler. At some point, maybe it would be nice to add, some kind of shorthand for these or something here. Or maybe that is just a concern of the assembler. The actual opcode doesn't need to encode that information. But anyway, it's very much just a very simple translation from strings into this. And I started thinking about what it would be like to write a program that calculated a Fibonacci number. And I very quickly realized that I was going to need some kind of macro system to do it, because, for example, let's ignore this stuff up the top for now. Let's say we're just having a simple program, right, where we define some number at the top of the file. We don't have I/O from this machine yet, so everything's kind of hard-coded in some way. But we load a number, we call a function, we exit this function, does some stuff, calls itself recursively. So we need to do some stack operations. We need to kind of manage that stuff. We need to have some kind of function calling convention. We have a return, and these things are just kind of macros. So I realized that we actually need some kind of macro system. And that's what I made. And the macro system, you define a name for the macro, and then you give a list of /separated lines that just get substituted in and then evaluated. And these could contain more macros. So we defined a calling convention, which is quite verbose, just using this macro system, and that's great. It highlighted some flaws in the machine. Maybe we don't want it to take 1, 2, 3, 4, 5, 6, 7, 8 instructions to call a function. Maybe we need more specific instructions to support this. But anyway, we can, if we have a sensible call and return macro that's kind of in one place, a bunch of programs can use that, and we can change the machine out from under it as we go. That's kind of a cool idea. My goal today is to build this assembler. Now, I have actually, in between streams, played around and built this assembler, okay? Let's have a look at the code, right? So an assembler that does this, an assembly preprocessor, which is why this file is called PP. So a preprocessing pass that takes that file and generates something our current assembler can use. It's 100 lines of Python, more or less. It's very, very simple. It's very, very, very simple. It's just simple. The two-pass thing is kind of fun. Well, anyway. I wrote it in Python. It kind of works. We're going to rewrite it better in Rust. Let's just show that it works, right? So let's go back to, I don't have this still open. let's have a look at our fib program with all this stuff, right? The actual assembly, there aren't that many instructions. If I run the preprocessor on it, we can see it generates a bunch of instructions. Let's less that. So yeah, you can see it generates quite a lot of stuff. And most of this is just manipulating the stack for calling a function, which is kind of cool. And it calculates offsets of branches. It only does absolute jumps, which was a little bit limiting. Anyway, we're gonna write this. So let's make a branch. Let's call it assembly preprocessor, which is a bad branch name, but will survive. I also have this pp.asm file, which was just a test. Excellent. Oh yeah, because I did. Okay. See, I read this like a week ago. I've kind of forgotten what I was doing. I have a very short attention span. Okay, let's start writing Rust. Let's stop talking and start writing Rust. So we're going to go into our assembly binary. And, this is 50 lines. It's not that long. But actually, what we probably need to do is to turn this into a folder. Did that work? It didn't, because I spelled make dear. Right? So as it stands, we're just running these files, source/bin/binary-name.rs. This gets compiled, or this gets built into a binary. What we're going to do instead is, now what's the file called? What is it? Cargo binary targets. Excellent. What's this called? Cargo targets. Bin. It looks at. It tells us this. Doubles, dependencies. Individual binaries, source bin. Yeah, source bin. Yeah, so it's just main.rs in this way of doing it. So we're gonna quit this. We're gonna move source bin asm.rs to source bin asm main.rs, and now we should still be able to cargo run, and it runs the same, which is great. Let's clean up these parentheses. This is kind of annoying, isn't it? 74. I think I said I was going to do this last time, but then I didn't. Excellent. No warnings. We can just power on with code. Okay, so let's edit source bin asm main.rs. Now, this approach is going to have to be a little bit different than Python because it just is different. So let's start with the simplest thing first, and that is variable substitution. Okay, so let's pull up our example program. It's not in sources, it's in progs, fib asm. If we encounter a token that starts with an exclamation mark, this is a variable. We need to substitute it with anything that had been defined as. This is good as well because we can define our signals instead of just using magical numbers. Signal sig_exit is a lot more meaningful than signal hex f0. We understand that this should exit the program, and if it doesn't, something's gone wrong. We don't need to understand magic numbers anymore. We start to build up more of a convention. So now, before we call instruction from string, we kind of want to unpick the line, do any kind of substitutions we can, and then do this thing. Or we could kind of think about doing this in two passes as well. We could do a pass where we do this preprocessor step and expand everything. I don't see why I wouldn't do this in one pass. I might regret that, but I don't see why we wouldn't do this in one pass, right? Because these, we're going to have this first pass, well, we're going to have these two parts. We're going to have this step that expands everything like this, that expands our macros, and then we're going to have the step that translates, load am5, like this exclamation again gets substituted for 5, load am5, this gets translated into the actual bits of the assembly of the machine instruction, sorry. But, these two things are in completely separate words. Okay. Oh my god. I thought I was muted. Sorry. Oh, I just had a small heart attack. Let me just double check. Okay, good. I can hear myself. Crisis averted. Load A immediate, 5, right? These things are in separate worlds. The step that interacts with defined variables, defined macros, these are going to be very separate concerns. There's no way when we're converting something into a pattern of bits that we care about what the state of variables or macros are. So I think we can do this all in one go. So what I'm saying is, we have like a pre-process here, right? So we turn line inner, now there's a split method, right? Well, let's say preprocessor. Let's not even call it preprocessor. Let's just call it processor dot resolve line inner, right? So in other words, we're gonna have something. What is this thing? I don't know. Let's make it up here. Because this thing's gonna have state, it needs to actually be some kind of thing that we create, right? It's gonna store variables. It's gonna have state. Okay, so let's start with a simple example. Let's go source bin ASM. Let's just call it PP. I like the name PP for preprocessor. Let's go struct preprocessor. We're going to have a map of variables. And this is going to map string into string. These are just strings, right? We don't care if it's a number. We don't have this kind of concept of type here. Everything's just a string. We're just mashing strings together. This is the joy of a preprocessor. Okay, so we're gonna have new, and new is gonna return a self. And all this does is give us back this type. Variables is going to be hash map new. And do I have to use... I think I do. Okay, cool. So what happens if I run this? Well, it should fail. It should blow up because it doesn't know what this is. Okay, so use... what am I saying? Use... Oh. Whimsically Made in chat says, this is very visually appealing. Thank you. Thank you. I had a haircut the other day, so I'm feeling very visually appealing. No, welcome. I love when people stop by, and I promise I don't always make bad jokes. How do I do this again? Oh my gosh, I'm blanking on... I set all this up, and I haven't written Rust for a few weeks, and I'm like, what am I doing? Is it crate? It's not crate, it's oh, it's mod, isn't it? Isn't it mod mod pp? Exists but is inaccessible. Yeah, cool. Undeclared type. Yeah, and so then it's use. I do love that the Rust compiler does just give you that little push, because sometimes I need it, because apparently I forget stuff. Now we need to actually add the other function. Resolve. This is going to take a mutable reference to ourself and give us back something. I guess a string. I guess it probably needs to be a result string. I'm not sure about namespacing here. Maybe I just need to call this like, and then we can have some kind of, pub enum error. Is this how you do error types? Is this good practice? I'm not sure. And this is just going to be, a generic kind of wrapper. I'm going to try and use more structured error types here because I think there's more interesting stuff that can go wrong here than in any other part of our program. Okay, so for now, Oh, this needs to take a string as well, a reference to a string. Excellent. So we're going to return string. I think this is a method. I think this is what we do. No from stir. Yes, from stir use std. Was that? I didn't pay attention to what it actually told me to write. Stir from stir. Perfect. It's weird that you have to import traits, but anyway. Oh yes. String infallible. The type contains due to the type infallible. Okay. So maybe I just then need to map the error type, right? So X goes to cool. Dot. Well, I guess these messages, nah. Can I do this? Does this work? Does this? I'm just sick of writing toString everywhere. No, because is this? No. Okay. No. That's a kettle of fish. Okay. We're just gonna write toString. We're just gonna write toString. I don't know. Dealing with string slice versus. Okay, this is good. This is good. Excellent. X is unused. Excellent. We can get rid of that. Cool. Unused variable processed. Yes. This sounds really good. Cannot vary processor as mutable. It's not declared as mutable. This also returns a result in a way that I didn't really plan. This needs to be mutable because this thing has state, right? We're going to define new variables. We're going to define new macros. Stuff is going to move and change and happen. Cool. Let me just pop my chat out for 1 second to delete a little spam message. This has all changed. The way I would usually delete a message is not there. Maybe I'm going to have to investigate this more. Oh, can I not delete them? Do I just have to like kick the person out? That's a new promotion to your channel. Promotion to my channel sounds very tempting. Let's get this guy out of here. Okay. There it goes. Perfect. Perfect. Thank you for bearing with me through that very stressful time. Whimsically Made, thanks for following, by the way. Sorry, I did miss that. I think you followed before I started streaming, which is cool. Bit of ESP. but I love it. Okay, so process resolve. Excellent. So the goal is that we have this unexpected string. Now I can do this. Right? First things first. This is good. So we have a function right now that does nothing. We have a preprocessor that just returns the thing. As long as we can actually convert the stir back into a string, which would be kind of funny if we couldn't. Now, if I look back at op, I think I did this already. If I look maybe at the macros, I have an error type, right? That is defined in op. Yes. Now apparently I can implement something here. I can implement like toString maybe. Implement into string. Impl from stir display. Oops. Display. It's not display, is it? Any type implements error, it also implements display. Okay, so implements error, toString trait, implement for any type that implements display. So I need to implement display. I need to implement display. Okay, that is, I did this before. I did this like the wrong way before. So I need to implement display. Let's just go copy paste some code that I've already written. Oops. Excellent. Okay, so match self unknown FMT what is it, right? Cool. This is okay. Unknown not found in the scope because, and then I also need to use format. This isn't called FMT, it's called F. Expected string because of this. From Panic. Good way. Damon definitely told me how to do this, and I've forgotten. So that's unfortunate. We're gonna do my janky thing. We're gonna go back to the janky way for now, and then Damon can yell at me in a YouTube comment. Perfect. Perfect. Okay, so this works. Let's test it just to make sure. Excellent. That may or may not be correct. That's something that could run. It may or may not be correct. So we can now have a preprocessor that does nothing. This is a good start. This is a good start. Okay, so what do we actually need to do when we resolve input? Well, the first thing is to split the input. And apparently there is a better way to do this than what I had been doing. Split. Yeah, okay. We can split on a space. Let's make a nice vector of the parts of the string. I want to filter out anything that doesn't, with a length less than 0 maybe, but let's wait to do that. So we have the parts of the string. We have the parts of the string. For each part, if P right, if the first character is exclamation mark, then we want to look it up as a variable and replace whatever the part of this string is with that character. Right? Does that make sense? So we have a line of input. We look at all of the parts separated by spaces. If any of those parts, hold on, this, I can't do that though because the length may be, okay. This is okay, this is okay. Parts, p count nth equals 0. and then we have to rejoin them. So actually, this isn't an iteration. Let's say let map, right? This is a map. This isn't a loop. We're mapping each part of this string to something else. Now, this returns an option. This returns an option. Right? So all the different things a character could start with. We're gonna have a few. I mean, for one thing, if it starts with a semicolon, maybe we just have to skip the entire line, but we can get there. Okay. Resolve variable. And this is gonna be Rust string slice. This is gonna be this is gonna be well, can we just go like 1 ... Can we do that? And let's maybe say pub. This maybe isn't even pub. Get variable self. Can we return out of this? Yeah, this is okay. This is okay. Return error. Token P. Does this unbalance the whole return arm? Maybe this is okay. Maybe this is okay. Okay, now we need to rejoin it. Can we somehow collect a vec into a string? Does this work? Wow, apparently there is actually just a join method. So let's say resolved join, and this is going to be, we're okay with this. Now this is going to blow up for a couple of reasons, I'm sure. Unclosed delimiter, perfect. That's the kind of thing we like to see. These things are easy to fix. We didn't close this in our map either, so that's good. Unused import from stir, you're gone, you're out of here. Vector is not an iterator. Yeah, of course. We need to do that first. Method takes 0 arguments, but 1 argument was supplied. That's because so this is good. This is just playing whack-a-mole with all the things I've forgotten. For example, I forgot to borrow here, but that's fine. Match arms have incompatible types. P. This makes sense to string. Okay, now this is weird because expected result error found string, right? So on line 31, Like, I don't know where this result error is coming into it. Also, hold on, I'm doing this thing again. I'm doing this thing. What I need to do here instead should be, because this returns an option, right? So it's get variable p1. Okay, or right, we're gonna use the actual tools at our disposal to do this properly. P. And now we can just use the no, hold on, yeah, we can just do this. We can just do this. Gives us back a string. Okay, perfect, perfect. This function should return a result or option to accept. We're in a closure, so we can't just do this necessarily. Okay. See, this is this thing where I want to think kind of Haskell-y. Maybe resolved should be a vec of right, and then down here I want to turn this into a result. Right, I want to turn an m. What is it? It's an m of, or it's an a of b of x into a b of a of x, right? If that makes sense. I want to invert the monads. I want to put the result on the outside, and I can do this. Collect does this. Okay, so let's get rid of this. Let's do this. Okay, now resolve dot into iter result vec. I'm pretty sure collect knows how to do this because it's kind of freaking magic. Okay. Supplied one generic argument. Yes, that is because I did this. I messed my brackets up. Okay. And that's it. And it just works, right? Collect understands how to do this. This is magic. This is kind of magic. Okay. So what happens now if I run this? It appears to work, which is incredible, Okay. Now. Okay, stay cool. So we've... Oh, this is so cool. I seriously, I don't understand what collect does. It just seems to do everything, but it knows how to invert our monads, which is great. Okay. So let's just say, right, that's now variables is actually used. Like this, maybe. Cool. Perfect. And I guess this just works. So let's try it out. First off, we need to... Well, let's add a function. A function that's going to define a variable. What's the method called? Crap. I always forget. Insert, that would be it. It's one of the hardest things working in different programming languages, what the list insertion and hash map insertions are called, right? That's all good. These just have to be to string and this just has to be a toString. Just put a little semicolon there. And that looks good. Okay, we never use this, so that's good. Process, oops. Processor.define variable. Let's make a variable called foo, and let's give it a value of 5. Let's also add a flag. Let's maybe put it up here. Let's add a flag so that if pre-process only and our output's just a list of strings. Oh no, it isn't. Our output is our output's a list of bytes. That's okay. We can still do this. We can still do this. Let's to string to U8 as bytes. But this isn't, when this is like append or concat or something. Types different mutability. Okay, let's go into Vec and let's find out. Let's find out what's going on. Let's find out what's going on here. Vec, append. Needs solve other needs to be mutable. Leaving other empty. No. I want this, but without the mutable part. Push. What's this? Concatenate vectors, yeah. Okay, maybe there isn't an easy way to do this. For B in processed as bytes. Output append B. And there's nothing wrong with this. Okay, so now when we run this, found reference U8. Oh, because I meant to say push. That checks out. Can you do this or something? Can you borrow this in the... Yes, you can. Excellent. Why is there no output? There is. It's just all on one line. So it never gets flushed. This is a nightmare, and this is kind of bad string handling. Cool. Okay, that's good. Nice. This works. This works. Okay, so now let's just make maybe this file, right? This is a good test. And we would expect this to error. Unknown token bar. Perfect. So we're trying to resolve a variable. We don't know what that variable is, and it yells at us. That sounds good. That sounds like the kind of thing we expect. So let's come back up here. And this is janky, right? We're going to add some kind of like command line flag to control this, but we're not going to do it right now. For now, we're just going to turn this into a simple pass. Bar B. Excellent. These get substituted variables. So let's just remind ourselves what's going on here. right? Where we see exclamation mark variable name, we substitute it with the variables that we define here. Excellent, excellent. Let's head back into our preprocessor. Let's dive in. Let's actually commit here. What are we saying? Cool. Okay. Excellent, excellent. Now we need a way of doing this kind of macro substitution where, and the syntax I've used for this has been, dot macro name and then just a list of arguments. So where a macro is going to be basically just a function. It's just going to be a function that takes these things. Now, defining a function like this can be a bit annoying in Rust, right? Like an anonymous function like this. So let's try and do the naive thing and see where it breaks. So let's go macros. This is also going to be a hash map. It's going to be a hash map from a string Rust function types. Let's actually make it type for this. Function pointer types. What does this look like? F type. Okay, so it's going to take a mutable reference to a preprocessor. It's going to take a vec of string inputs, and it's going to return a result. Right, so it's going to take things in, and it's going to return lines of output or an error. And this could also be empty, right? In the case of it doing nothing. Right, so it's going to look like this. It's going to look like this. And this just warns us about dead code, which is great. So what if we say pub fn define macro? What happens if we just do the most naive thing possible? Is this just gonna work? Define macros never used. It looks good. It looks good. Okay. So let's go back to our ASM maybe, and let's say, well, actually, let's make them. Let's make a couple of. So we've got kind of an option, right? We could keep this preprocessor very pure, and maybe in a sense we should. And write our macro functions somewhere else. So maybe let's go use create pp preprocessor. Okay. What do we got? So let's make macro def var. The other thing is we could like, we're only going to have a few things that are macros. Maybe these should be like built in and hard coded. For example, like def var is going to be built in, a few other simple directives, and then we're going to have def macro, which allows us to define new macros. Maybe these are just separate concepts. Anyway, let's try this for now. Next string error. Okay, so this also needs to be pub. Okay, so what does this macro do? Well, all this does, if input len, if the input length, it's going to be value. So if it's not 2, then we're going to say error. Let's say must have 2. Okay, so if the input length isn't 2, then that's a problem. Now we know the input length is 2, we can say let name equal input dot get 0, and we can just unwrap it because we've checked the length. Value input get 1 unwrap. And then we just say pp define variable name value. And I think that's good. Let's see if we can do this. What else are we doing? What else have we got? Define macro def var. Cool. What happens if we run this now? Does it cry? It does. Ah, that's a special word. What if we call it macros? Okay, that's good. So let's move bin macro, bin ASM macro. That's kind of funny. I forgot that was a reserved word. Gotta respect the language's keywords. Okay, unclosed delimiter. This is the kind of thing we like to see. This is easy. That doesn't exist anymore. Bin ASM macros. Okay, we need to be careful we don't edit the old one. Unclosed delimiter. Lovely, lovely, lovely. No macro def var in. Oh, of course, that's because I included it from the wrong place. That is just a typo. I forgot double colon. I really love how easy it is to hone in on these errors with the Rust compiler. I never feel nervous. Expected string found. Stir. I probably need to rethink this error handling even more, because it would be nice if these got enriched. So I could just say this, and then the next layer up wraps it in the name of the macro, and then the next layer up from that wraps it in the actual line that it happened with a line number. We can be much smarter about this. Okay, so that's good. Okay, this didn't blow up. That's good. But we don't actually have a way, like macros never actually get called, right? So what we need to do is to come into our p preprocessor, our pp, and add another case here. So if the first character is a dot, this is going to be our hook into calling a macro. And we're going to do the same kind of thing, okay, or actually, yeah, error unknown. Excellent. And then we're just going to call this function with our self and with the input to the macro is going to be the rest of the line. No, hold on. This only works if it's the first thing. You can't have a macro midline. This is different. This is a different path. Or is it? No, this is a different path. This is a different path. I got carried away. I got excited. So actually this match is probably a bit unnecessary. So if parts len is 0, then we're just gonna then we just return okay. We just return okay. It's empty string. Right, there's nothing to really do. Otherwise we're gonna say parts get 0 unwrap. Because we've just checked the length, we can unwrap. This may not be the best way to do it, but we're gonna survive. I guess we could also say if let sum x equal parts get 0, and we know this will always go through, but we don't have an unwrap. Maybe that's cleaner, I'm not really sure. Would love some feedback from Rust people. If Rust people have opinions, please yell them at me. Let me just do a quick sound check. It sounds like I'm still good. It sounds like I'm still okay. Can everyone hear me? Am I alive? I get nervous. I get really nervous when I'm writing code for a while. I'm like, can anyone actually hear all this lovely stuff I'm saying? Because this is high quality content. I don't know what I'm doing, but I hope people are enjoying. Okay. Might be time to stretch in a minute, actually. My mind might be starting to wander. Let's get this macro calling working, and then we'll think about taking a little break. Okay, so if let sum x, so if the first part, let's maybe call this head, match head chars nth 0. Okay, so if the first character is a semicolon, then we oh, hold on. There's another thought in my brain here, which is are we really gonna return out of this? I guess we have to. Okay, this is okay. This is the weird path. We just return okay. And I know, we just return the input, rather. Do we have to... Can we do this? Okay. If the first character is a dot, then we're gonna say... We're gonna do this macro stuff, but we're gonna have to return something as well. Okay. So... We're going to do the same thing though. Func self get macro p1. But this is now head 1 ... I love OKOR. OKOR is my favorite thing. Okay, now we have a function. We can call the function. We can call it with ourself and with input, parts 1 ... right? So the rest of the parts. Because this function returns a result, we can question mark it. Now we're gonna say res.map. Because the function the macro returns things that then in turn need to be processed. Let's just ignore that for now. Let's just say okay res.join. Except these are lines. Is it? Yeah. Yeah, that's fine. That's fine. Okay. But we need to return. And then the default case, we don't know what. Well, we just do nothing. We just do nothing. This is gonna yell at me. This is really gonna yell at me. Error unknown. This needs a semicolon. Whoa! Some stuff just fell over. We're all good. We're all good. Just a box of masks. Lovely, lovely. Empty string. This is not my friend. Now, rather than converting this to a string, I suspect I can just make a new string. And it's annoying to have to do that, really. Like, it doesn't feel like the kind of thing I should need to do, but here we are. ToString is a method, not a field. I just forgot some parentheses. Okay, get macro. There's no such method or get macro. That's lovely. My parentheses are wrong here. That is also lovely. I thought that felt like too many parentheses. It felt wrong when I wrote it. Okay, here we go. So let's do my favorite thing. Get macro self name. And I'm, rather than just using the maps directly, like these methods really don't add much value. I could just be calling this, directly. I'm doing it this way because I'm not really sure what the kind of scope namespace stuff will look like. So I'm just going to keep it, I'm going to add that layer of indirection so that if I change the underlying representation, the code doesn't hopefully need to change much as well. Macros get name. Except this isn't a string anymore, and I probably don't need to clone it. Now it's a macro func. Unexpected argument type. Expected string found stir. Yes, that's because unknown format. I forgot to put a format in there. That's great. Func has type result for, this doesn't seem right. This doesn't seem right, and it doesn't seem right because I forgot to put a question mark there and unwrap the thing that I'm actually getting. Okay, parts, 2vec, expected, found a slice. Oh, right, hold on. I'm not meant to use vectors in function signatures, am I? It's better to maybe do this. Right? Can't you cast a vector to a thing every time? I've just added another layer of things that are going to blow up. And now I need a named lifetime. No. I don't want to get into this. I don't want to get into this right now. That's my first lifetime. Baby's first lifetime. That we've seen on this stream anyway. Okay. Expected vector found slice. Okay, where is this? Where is this? Mismatch type. 72. What? What? Macros get. What arguments to what? Mismatch type. Expected what is this pointing to? What is this pointing to? Okay. Option. Expected option, found option. Okay, so is this maybe a ref to a macro func? That appears to have worked. Perfect. Parts 2vec 43. This is interesting. This is very interesting actually, because I thought we did this. Oh no, we didn't. Yeah. Expected struct found slice. What if I do this? We can't. Oh, sorry. I put that in the wrong place, didn't I? Nice. Okay, now we're cooking with gas again. Unknown macro include. Perfect. This is good. This is good. Let's just get rid of this stuff. This is good as well. Okay, so we're running into another problem here, which is that like this doesn't really mean anything. So we're going to go in, we're going to rethink our errors a little bit more. We're going to rethink them a little bit more. So let's maybe say unknown's a bad name. Error other? That's also a bad name. Let's say unknown token. So like we've hit a thing, we don't know what it is. That's great. That's really, really good. And really this is just the message. Unknown token. Like these are the same, but one of them has more context, right? These error types are good. But what I really want here, yeah, this is nice. This is nice. Okay, what I really, really want here is when a macro fails. Okay, so let's follow this path up, right? A macro is gonna run, and it's gonna fail. I would love to enrich this error, right? So indeed, maybe not even. So let's say a macro eval, maybe. But macros can fail with... So I want it to reference itself. I don't know if we can do this, but we'll find out. This might be problematic. But I want a macro to be able to fail with an error that is also an error from evaluating the stuff, because a macro is going to do things like resolve variables. It's going to hit unknown tokens. It's going to potentially resolve other macros, maybe? Maybe this is unnecessary. Because, okay, so how does define variable fail? Well, define variable... It just doesn't fail. Okay, we'll get here, Let's try this for now. If this blows up, then so be it. Okay, or... So get macro is okay, but we want to map air here. We want to map it to... macro eval x, and we want this to also, because now we have the name of the macro as well as the message. This is the kind of extra context that's useful. Okay, expected following match arm. Yes, that sounds like something I would forget. That is believable. Okay, pubinum error recursive without indirection. So we can't do that. Unless it's just a string, right? Unless macro is just error with a string. Not even this full error type, just some generic dumb message. Let's try this. Macros. Oh. This seems better. Unused import, that's good. Okay, unknown found for type here. That's of course not correct. What did I call this? I called it other. Except now, instead of just having unknown, let's say unknown token, and now we just have the name of the thing that is unknown, right? We don't have to have this other information. The type of the error infers extra context. Mismatched closing delimiter on line 58. That is because I changed something. Okay, macro eval, try the conversion method to string, that sounds good. Found stir. Okay, yeah, so I'm over relying on string here. I probably need to start thinking about lifetimes and making this a bit less gross. Maybe that's a topic for next stream. Maybe it's a topic for today. I can keep going. I'm not in a rush. Expected string found stir. Yeah, now it's getting a little uglier, isn't it? This is a lot of heap thrashing for nothing. It's like I'm writing Python or something. Come on, come on. Expected string found string. That's okay. I can. Found string. Remove the bar. That works. I'm racing to get this working. Okay. Nice. So now it says what macro was evaluating and what the error was. Now let's enrich this even more. Let's go into our main and let's say for I line in lines enumerate. Can I do this? Is this legal? I think this is legal. Okay, so now we have the number of the line in the file. We have line numbers. Excellent. That's the result, blah, blah, blah. Okay, we need to catch this error somewhere and do something with it. I think some of this should be nested in another function. I think that's kind of where I'm landing here. So let's write two more functions. Let's write function which is going to take mute vec u8 for output. No, sorry, which is going to take a string in and give us a result string. Can we do that? I don't know. Let's just do string out. Actually, this is so small, I don't think it's worth it. But let's say, out, which is a mute vec u8. I guess we can also panic. I'm just struggling to imagine what this looks like. What is this? Like, this thing can fail. We need to grab the error out. We need to do something with it. But then we also want to not do this bit if preprocess only. Maybe doing this in 2 passes is smarter. maybe that is better. Because then you just die, you just stop. But then you need a mapping between the line in the source file and the line in the preprocessor output, otherwise you get funky line numbers which aren't useful. So this has advantages. Okay, I just need to see it. I'm gonna take a quick breather, run to the bathroom. When I come back, we will solve this problem. Alright. Alright. Isaac CC, thank you very much for following. Welcome. Welcome. I hope you're enjoying this struggle. For one thing, we need to do something about this. This is, let's put a quick to do here. Need to fix this. Okay, so we're just thinking about error handling real quick, and I really want to annotate these errors with a line number because this is going to get increasingly important as our assembler does more interesting things. Okay, so preprocessor resolve, processor resolve. This gives us back potentially an error. So maybe, I mean, do we just like do we just panic? Can we match? Does this work for now? Can we just say line number can we say IE? Is that, can we do this? We didn't move this out into a function. I think I'm overcomplicating things, right? I am overcomplicating things. Look at this. It gives us a line number. It's still not quite pretty enough, but oops. It works. Line 0. It tells us that when we evaluate the macro defvar, the format is incorrect. This isn't a great error message, but it's a hell of a lot better. Regs987, thank you very much for stopping by. I just heard a very important noise. I'm gonna have to go deal with that in a second. A fun noise, but an important one. Okay, so let's jump into the file that's complaining because we're just goofing around with some stuff here. Let's try and define the variable foo in here. So let's get rid of our hard-coded variable names and see if this carries over. And that looks like it works. It looks like we have defined things. Foonex, yeah, so this substitution works. So we can define macros, that then mutate the state of the program. That's pretty good. That's pretty fantastic. Now, labels we're gonna have to handle as well. That's not too hard, but for now I think this is a good place to maybe do a commit. Source bin ASM macros. What's going on here? But yeah, Rigs, I'm a Rust boy now. I write Rust. I'm gonna do more PS2 stuff. It's still on the cards, but for now, just enjoying learning a new language and tackling some new challenges. And really excited to get a little virtual machine that can hopefully run in the browser. Okay, so bin ASM. What did we do? We macro. Ideally, that should be 2 commits, but we're playing a little rough. Here. How did the PS2 project go? I kind of stopped working on it because I got a job that was really hard. It just took a lot of my coding energy, so it's still on the burner. I have played around with a little bit of 3D again. I'm getting there. My Lua stuff is a lot cleaner. I have better tests, but it's still a work in progress. And I'm going to live stream more of it, hopefully soon. I'm close to doing fun 3D stuff, and there's a cool, like some other people are doing some cool stuff, which has been very inspiring. Very, very inspiring. Okay, so we also need to do this here as well. So let's say line here, error. Excellent. When we fail now, we know what line we failed on. This is kind of important. This is kind of important. 'Cause let's just actually commit all the things I wanted to commit. Oh, connection's pretty bad. Your end or mine? Look, it looks healthy on my end. My bitrate looks good. By connection's pretty bad, what do you mean? Do you mean just like low video quality? Cause this is 4 megabits per second. It's not ideal stream quality, but it's okay. Yeah, let me know. Let me know how it looks. It looks okay from my end. Okay. So another thing we want to do here is labels. And labels just count a number of bytes offset from the start, right? So like the number of lines from the start, number of bytes from the start. Let's say number of bytes from the start. So every instruction we encounter is 2 bytes. And this is another really good thing about not having variable length instruction encodings. It's just, we know that every line is 2 bytes, so we don't have to do anything fancy for labels. We don't care what's in the instruction. We can always work out what a label should represent. Okay, so let's do labels. Let's do labels. So let's go into our preprocessor. And now these are just going to be variables. They're just going to be variables. Now, the way I've written it here, I've gone for the last character on the line being a colon. And I kind of like that, but that's going to be a third kind of matching. So we're going to have matching the first character. We're going to have matching the first character of each token within a string. Yeah, Riggs, maybe try another stream and see if it's also lagging there. And then if it isn't, I'll see if I can, if there's anything going on, I'll work it out. But if anyone else is having a connection issue, please let me know. I would love to know, so I'm not just kind of wasting my time here. For now, let's just say the first character is going to be a colon for labels. So in other words, we're going to change, we're going to change it to this. Okay, so if the first character is a colon, let's say let name equal head. So let's get the name of the label. Let's line count times 2. So for every line, that's going to be 2 bytes. And then we're going to store this as a variable. I think that sounds okay. That sounds pretty good. Now, ideally, we would probably be able to do math on things and say like variable plus 1 or something. That's all a concern for another time. For now, we're doing simple stuff. We're mashing strings together. This is like the C preprocessor. Okay, we're dumb. I don't want to be smart. I want to be dumb. So preprocessor, we now also need a bit of state called line count, which is just going to be a U32. And this gets a bit more complicated because now for every line that is a thing, we need to actually increment this line counter. So for example, this we do not increment the line counter, right? Because we're only counting lines that have instructions. So maybe this should be instruction count, actually. Let's call it instruction count. That's a much more meaningful name. Okay, so when we have a macro, we don't increment the instruction count. When we have a label, we don't increment the instruction count. When we have a variable within a thing, we don't increment the instruction count. But when we get to the end here, so here we actually do. We say self.instruction count plus equals 1, right? Because it's not a comment, it's not a macro. It can have a variable in it, but that is an instruction. Okay, so we would expect this to say baz and then whatever the offset of EEE is within the program. So that's going to be 1, 2, 3. So we should expect this to be 0, 1, 2 even. We should expect this to be 4, I think. We also need to set this instruction count. We initialize it to 0. Okay, so now if I run this, oops, that would have been bad. Define variable expected stir found string. I forgot I stirred this. Can I just borrow it? Does that work? Is a borrow okay? And then I forgot, well, I have too many closing delimiters, the curse of my life. Now, instruction count is borrowed. It's assigned, but it was already borrowed. So we reference it, right? In line 65. Do we? Or we borrow it? Because P is borrowed. What about this? That's okay. Okay, so because of how resolved is scoped, I guess, because the things in resolved are no longer relevant, especially because we're collecting into a string, we can mutate self after this line, but not necessarily before it, I think. That makes sense to me. And this, as expected, prints 4. Now, for some reason, this label has still ended up in the output. That's not correct. That is not correct. So we need to actually return here as well. So let's say return OK string new. Okay. Excellent. Now this label's gone. This label is out of here. Nice, nice. Let's maybe... let's jump into main as well, because there's something that's bothering me here, and that is if processed len, I think, is empty. Maybe it's just empty, right? But we only want to print things out if the line isn't empty. Otherwise, yeah, we can just skip it. We can just skip it. And then we get a much denser output, which is good and bad. It's good and bad. However, the other thing we probably want to do with our preprocessor is retain comments, which we should be doing. We should be returning the comment. Don't know why comments aren't there. Anyway, okay, that's good. That's good. Good. Okay. This is sounding nice. This is feeling more like a real assembler. Okay, it's given us tools to work with. The other thing we really want to be able to do, actually, let's do this one too. Let's do include, because include is pretty cool. Macros. Let's see if we can do include. Macro include. Right? What include needs to do is, as the name suggests, let's say we have a line that says include lib.asm, which might define a macro like jump. If we have this, we want to paste in the contents of lib.asm here. It's like including a C header, right? It's going to be exactly the same, actually. So, if input len is not equal to 1, we only expect one thing. input.len. Okay, so let path. I'm going to borrow heavily from what we already have here. Oops. File open path new, we're going to borrow okay, so we grab a file. We grab a file and we want to read the entire file into a vector. So let's say let out equal vec new for in buff reader new file lines. So for each line in the file, we want to for each line in the file, push line. And then we just say okay out. Perfect. And that is probably okay. That sounds good. That sounds good. If I want to open, oops. Let's put some nice quotes around stuff because that's a bit nicer. How does this go? How does this go? Oops. Let's get rid of some redundant names. That's nice, isn't it? Like using the actual namespacing rather than duplicating the letters macro all the time. What happens when I run this? Probably something bad. Unused create macros. Well, this is good as well. Use create buff reader. Okay, yeah. That makes sense. That makes sense. Macros. Buff read, buff reader. I think I need both of these and use std file. Hopefully you can't hear the guy doing gardening just next to my window. Mod macros, use create, re-import it here. Oh. I don't even need to use it like that apparently. If it's accessible, it'll just be accessible. Use std fs file. Found line. Okay. Let's try this. Line. What is line? Couldn't convert the error to a string. Let's manually convert it to a string. Oh, trait from. Yep, that's because my question mark is in the wrong place. Okay, this is good. This is good. This is coming together. Okay. This is cool, actually. We don't mutate any state. And this is a cool way to do it. This is a cool way to do it. So, now when we run this, let's see what happens. No such file or directory. Failed to open. Oh, that's even funnier. Where is this? Failed to open. This is the actual error message, not the file name. So let's just file name That was really confusing. I was like, where's this file name? It was wrapped in this whole big error message. Now we've just unbalanced our brackets. That is good. Map. Oh, you know, I want that there. But then this has one too many. Okay. Unwrap not found in path. Because we've already unwrapped. Perfect. Okay. Failed to open lib.asm, no such file or directory. That sounds like a real error. Now let's say def var x5 def var y19. Now when I run this, unknown macro jump, that sounds very good as well. What does this look like? Well, we have these extra lines, but these extra lines need to be evaluated as well. There's no point just dumping this in here if we're not going to evaluate them. Now, this means we need to be careful, right? You can kind of denial of service yourself, because what if we said this, right? What would happen? Now, because now we're going to recursively evaluate these things. If you include a file inside itself, you're just going to loop forever. So that's a little dangerous, right? That's a little dangerous, but we're just gonna accept that for now. We're gonna accept the risks. We're gonna accept that it's up to people to handle this. But that we don't do this here. This is part of evaluating every macro. Every macro has the option to return text that we then continue to evaluate. Okay? So macro, the result. So instead of just joining this together, first we're gonna say, we're going to map the result. Each line in the result is going to get self.resolved. We're going to borrow it. Okay, res.map join .join Okay, now let's see what happens. This is probably very angry at me. What has gone on? Vec_string is not an iterator. That makes sense. We need to do the same thing we did down below, into iter. Into iter. Half of this stream I feel has just been making typos. No method name join for struct map in current scope. That's because we need to collect it first. And now when we run, current info type. You need to be very explicit with collect. Okay, now method cannot be called on vec result. Unsatisfied bounds. Oh yes, I need to do this thing again. So this is too much on one line. This is too much on one line. Okay, now we're gonna do the same thing as before. We're gonna say resolved is going to be a vec of result and now we're going to say return okay resolved join we're going to use the magic of collect again. Resolved, method not found in result, but I'm unwrapping this, right? Or do I have to do this here? There we go. Okay, that's better, that's better. Now this does seem to work. Let's put it really to the test. and not define these variables. And see what happens. And this pulls these definitions from the file. Now there's a bit of blank space up the top. I'm not sure what this is about. Not sure what this is about. We'll have to see, we'll have to see. And we can clean this up later, that's okay. That is okay. We're gonna have to do a proper CLI experience here and everything. At the moment, this is a bit jank. But this is good, right? We can evaluate all kinds of interesting macros. Now the real test is, can we write the macro? Okay, this is the test, def macro. Okay, this is the macro to end all macros. This is the macro that lets us add more macros for your macros. Now, unfortunately, because of how this works, like ideally you'd be able to say like def macro begin foo, and then like def macro end, or like maybe just end, and then you'd have bar baz, right? You'd just have a bunch of stuff here that would get substituted. Unfortunately, because this preprocessor only understands the concept of a line, it doesn't understand there's anything except just lines of text. We're gonna have to do something like this. Let's say jump. Let's imagine a world where, because we don't actually have a specific jump instruction, let's just call it test for now, right? And so what test is gonna do? It's gonna return foo x. Okay, so we're going to start with a one-line macro. But what if we want more than one line? What if we want to replace all these 3 lines with test? Okay, my thinking for this, for now, is to just use the slash as a character for this. Okay, and separate lines like that. That means that long macros are a little bit cumbersome, but that's doable, right? That we can work from here. This gives me something to play around with. I can start writing more interesting code. And maybe it's a good thing that I'm not able to do gigantic, stupid macros, right? Maybe at some point I'll extend this to be smarter, but for now, this seems to be the way to go. This seems to be the way to go. Oh. Okay. And like, how big do your macros need to be? How big do your macros need to be? So if I run this now, it's going to say, hey, on line 1, macro def macro. What is this? I don't know what macro def macro is. I can't do this. It's actually just real quick. Yeah. Okay. Let's fix this. Let's fix this. This is actually another unknown token, right? It's another unknown token. It's the same as this. And it's going to be head 1.to string. And now I have an unclosed delimiter, which is fine. It's also going to yell at me for having an unused variant, but that's okay. But that's good also. You don't necessarily, like, do we even need this? I don't know. We'll find out. We'll keep it there for now. We'll keep it as our fallback, but maybe we just get rid of that. Maybe every error has a strict thing that it comes from. Okay, so that's good. That's good. Okay. So I love this. This is feeling really good. Now, let's do the big one. What did I just do? I did this. Macro name not found, correct error. My commit messages haven't been great, but we'll survive. Can you hear the, can you hear this like leaf blower in the background? I hope not. It's okay. We'll be fine. Actually, I can shut my window. I might do that. I might just do that real quick. Excuse me for 1 second. Oh my gosh, that is instantly 10 times quieter. Amazing. Oh, sorry, Riggs. What are you using to build and run this project? Cargo. This is all Cargo. Cargo's amazing. If you haven't done Rust, Cargo just kind of does everything. We can say like cargo lint. What is it? Cargo FMT, sorry. And cargo clippy. And it's going to lint and format and make a bunch of suggestions, which is so cool. It's so good. I love languages that have these good tool chains. I really enjoyed working with Go. I found Go... what's happening here? Okay, I keep accumulating state. Oh, not state, but a bunch of stuff in the background, which isn't good. But yeah, cargo is really good. Sorry, I missed that comment. Okay, so let's go pub fn def macro. We definitely need to mutate ourselves. Okay. Now, this is where it's going to break. Riggs says they heard cargo was pretty cumbersome with importing crates and stuff. I don't find that. I don't know. I can imagine there are people that say that. I don't doubt that, but I have not found that. That's interesting. That's very interesting. Like it's maybe a bit slow. It's maybe a bit clunky, but like the actual crates, you know, maybe there aren't as many crates as there are in a language with a bigger ecosystem, but no, I haven't had that issue at all. Okay. I might run up to the next problem I foresee and then maybe call the stream there and leave us something to solve for next time. So let's say there's no required input length here. Let's say if input.is empty, no arguments. Okay, so we know there's at least something. So let macro name input get 0. And we can unwrap. We're safe to unwrap. This is great. Okay. We're going to make a new vector of strings. Can this... Hold on, let me just test my sounding real quick. Wow. It sounds like this leaf blower is not picking up my microphone at all. That's incredible. This thing is very loud to me. Okay, anyway, I'm not going to get too distracted by it. I'm okay. Lines. So for an input so for the rest of the input after the first element, so we're gonna build a line. If token, if it's not the slash character, then current line dot push token. Else lines push current join Is there a reset method or something in a vector? I don't want to make a new vector. Clear? Yeah. This is what I want. Okay. So this sounds good. So, Mad Supervillain, welcome. What is this? Joe Cool the Camel. Where does this come from? Who has this Joe Cool the Camel smoking emote? What is this doing in my in my chat? What is this? I love this. This is very very classy. Mad Supervillain. Yeah, Mad Supervillain, you know, he's known as one of Big Tobacco's lackeys. How are you going, Mad Supervillain? How's Tekken, and also have you written much Rust before? These are my 2 questions to you today. Now, when we evaluate a macro that was defined like this, we want some other special sauce, but we'll get there. The problem we're about to hit, okay, and this is a pretty huge problem. This is like a gigantic problem. When we try and make a function, it's just not going to work. We can't make a function that closes over the lines of the macro that depends on this input and store this in our state. We can't do this. So actually, let's change things up. Let's go into our preprocessor. We're gonna change macrofunc into let's make an enum, and this enum is gonna be called macro. It's just gonna be called macro, maybe. Is that okay? That's probably okay. And it's either gonna be a func it's either gonna be a func, or it's gonna be either it's a func or we're substituting it. Where did we go? New game honeymoon phase of the Tekken 8. Still haven't written a line of Rust in your life. That's disappointing. Rust, I mean, you've got to have a pretty big brain, but you've got to have a pretty big brain for Tekken as well, right? Got to learn all those frames and shit. We're gonna have to have some kind of macro body struct that stores the lines of the macro. Actually, we don't. I think that we just need the lines of the macro. Okay. Now everywhere we're using a macrofunc. This is good, this is good. We probably still need to borrow this. We just need to match. Okay. Now we just need to match on func. If it's a function f, we do this. And if it's the substitution that we do with the lines, we do something else. Okay, sound good? Sounds good. We get rid of the semicolon because everything's an expression. This is lovely. But yeah, no, so I'm writing a 16-bit virtual machine. It's going to be cool. I'm going to use it to do some fun stuff, hopefully in the web browser. That'd be a lot of fun. If we get lines, for now, let's just return the lines out. Okay, does that sound good? Does that sound good? This is still going to yell at me because I've done something a little bit wrong, I'm sure. Func not found in the scope. That makes sense because it's macro func. Okay. Size of the values cannot be known at compile time. Macros line 39. Size of this cannot be known at compile time. No implementation for stir equals stir. Perfect. Current line push, we need to be explicit and convert this into a string, which is great. That's very easy. We're just thrashing the heap. We're thrashing the heap. But, I've written a lot of Python, so it doesn't seem that bad, really. Okay, so expected result. Also, we didn't actually return anything, so that's good. We need the macro name, and then we're going to say macro func subst lines. And then we're just going to say okay. No lines, no output. Which is a little bit wasteful, but that's fine. Maybe we need to return some kind of like enum where we have an empty variant. We can say there was no response, but that's okay. Macro func. We need to pull in macro func. Okay, match arms have incompatible types. That's one of my favorite things to see. I love seeing this. So lines. This expression has type macrofunc. Expected vex string found thing. Can I say this instead? Can I get rid of this silly borrow stuff? Maybe? Does this work? Potentially? So the fact that this enum is called macrofunc and then I have a variant called func is a bit of a smell, so I'm going to call this macro. But then I'm going to keep this. I'm going to keep this. I did not copy enough of this line, apparently. Okay, good. So now we have a type that represents this function. But when we define a macro, most of the time we're just using a function, so that's fine. And in the public interface, this is the only kind of macro we're ever going to define. We don't want to define these weird substitution macros that will make sense in a moment, unless we're inside the package. So this is its own function that is not exported. Okay, cool. Closing delimiter. We missed a thing. Excellent. Macrofunc private type alias. That's because we just need to call it macro. And then we also have this. Define substitution macro. But okay, I guess it still needs to be pub, but we'll survive. Define substitution macro, macro subst. Expected vex string found macro. Yes. We actually don't care about any of the details of the macro type here. That's the real win. Cool. The match arms are wrong. Expected option macro because of return type. Got option. This is a bit weird. Oh, no it isn't. Because the return still says macro func, does it? No. Oh, but the type, this still says macro func. Yes, perfect. Cannot move out of func as enum, which is behind a shared reference. Data move here. Move a cursor between line, which is not implement copy. That's good. So we actually can't do that. That's illegal. Not allowed. Not allowed. Match arms having compatible types. Type vex string. And one of them is a borrow. Okay, let's just do the dumb thing. And copy everything across. Warning, def macro is never used. Warning, others never used. Warning, subs just never constructed. Define subs macro is never used. What? What? Oh, right, because this function is never called, this function is never called, and it's smart enough to work out that this function is the only function that constructs the variant. That's pretty cool. That's pretty cool. Okay. So we need to use def macro. Okay. Let's see what happens. It runs, and it runs because there's no reason for it to not run. Okay, okay. Wait, did that just work? Hold on, foobar baz. Foobar baz. I mean, that almost just worked the first time. I didn't even expect that to really do much, but and this is one of the benefits of having, you know, like I guess not much magic, right? A macro returns stuff that then gets evaluated again. So if we have a macro that defines a macro that just returns some lines, we need this to be a little bit smarter. We do want to do some thinking here, right? You know, when we hit this, we maybe want some special tokens. We want to be able to call it with arguments. Now, right now there's a problem, and that problem is the last line of this macro is getting monched. It's getting lost somewhere, right? This baz never comes through. So why might that be, right? Why might the last line be getting lost? And this is a pattern you see a lot when you're building lines of text with some delimiter. It's probably because we forgot to push the last line, and that certainly is what we're going to see, right? So we hit the end of this. We haven't had another slash. If current line... if it's not empty, then we want to say lines push current line join. Now when we run it, we get the extra line as well. Perfect. Okay. So what if we want to have some kind of arguments here, right? What if we want to say, right? What if we want to pass some argument through? So we want to say test 17, and we want this to be reflected in here wherever we see this kind of, you know, zero variable defined. Okay. Now we're getting into this kind of scoping question. We're getting into all kinds of gross things. And we can do this the pretty way or we can do this the gross way. And we're going to opt for the pretty way where we can. So if we're substituting lines, let's go lines dot into iter dot map. Okay. Then we need to collect. Oh my gosh, my Tamagotchi is beeping at me. Hold on, I'm gonna grab it. I'm almost done for the day. We're almost tidying up. I just do need to quickly check my Tamagotchi. Hold on. All right, quick breather. Is everything okay? Couple of poos. Couple of letters, oh my gosh. Getting a lot of mail. Excellent, okay. Just have an ice cream. My Tamagotchi is ready to start work. It's a very exciting day, but I will do that. I'll find a job, a career after this. You lost the game. Welcome to my chat. Thank you very much for stopping by with your wonderful name. I'm sure lots of people will appreciate this. Responsible pet ownership. Yeah, exactly. I got an early birthday present, which is kind of exciting. I'm on my second generation of hopefully many. It really just makes me want a Digimon, right? Apparently there's a re-release of the Digimon Digital Monsters that, you know, kind of fight each other, like the boy Tamagotchi. I used to play with them. My cousins had them. They would lend them to me over the school holidays. They were a lot of fun. I never knew what the hell I was doing. Probably made a lot of care mistakes, but it was good. But yeah, you lost the game. I'm doing good. It's a lovely day. Sun is shining. The skies are blue. I'm inside writing code. What more could you ask for? Excellent. So what am I doing again? Oh yeah, so for each line, we want to evaluate this line. We want to maybe pre-process this line. So maybe let's say for part in line split. Actually, no, let's say line split map. So for each part, and then we just want to join them back together. For each part, match, and this is like the thing we're doing down below, match p chars nth 0 if we get some exclamation mark. Then we want to try and parse this as a thing. We want to try and say maybe we want to evaluate it with these parts, right? Yeah, the Digimon ones were a lot of fun. They were cool. Like, they could fight each other, you know, it was great. It was the simplest, jankiest combat system possible. I don't think you got to do anything. I think they just had like a power number, but it was fun. You needed a friend that had one so you could make them fight each other, so you got more like training points. It was good. It was really cool. So I don't know, buy them for your friends. Apparently they re-released them and they're quite cheap. I really need to look into it because that's a bit of nostalgia that I want. Okay, macro eval name cars nth. So we want to say maybe like a U32 from Radix, I think. Radix, I think the number is. Let's maybe go pull up U32. Radix. What is it? From stir Radix. The string is going to be p1 ... and the radix is going to be 16. Let's do 10. And this is a thing with a parse error. So we'll map the error x and then we can just, oh gosh, the nesting is getting intense. Okay, from stir radix. So this, we also probably need to borrow this as well. So the error, we're gonna say error macro eval name, not name, sorry. We're just gonna say x. We're just gonna use whatever formatting comes out of the box. Excellent. Okay. So if it's a digit and that's a, wait, no, that's not it at all, actually. Hold on, whoa, match. We want to match this. Because if it's not a digit, that's okay. I'm getting carried away. I'm thinking about Digimon. I probably need to stop soon. So if this is okay and we have a number, then we want to try and get that numbered argument from the parts. So okay. If n is greater than or equal to len parts len Digimon on the brain. I always wanted the like bigger Digimon, right? Like the little ones were fun, but I always wanted like the big handheld ones that cost like more money, and it was never on the cards apparently. Okay, so crap, this is another thing that can fail. Okay, if it's too big, we're just gonna give you back P. Else, we're gonna give you back N plus 1. Right? Because 0, well actually no, let's not do it. Let's just give you back N. Let's just give you back N. That sounds good. That sounds good. Okay, let's just give you back. I can't deal with something that isn't just a string this far in. This has to be okay. And if you get an error E, then but we're inside a map. No, I can't do this again. Hold on. Okay. Index too high. Parts is going to be a vec string, a vec of result string. Okay, it's going to be one of these again, and we're going to deal with it. But also, we've overloaded the name parts. We're just going to call this MP. We're in bad name town. We're doing this thing again. We're going to say mp.into iter. We're going to let collect do the magic. And we're going to do this thing again. It's a bit gross, but we're going to do this thing again. This is going to be the wrong error type, but it's okay. We'll survive for now. Okay. We're almost there. We're almost done. If there's an error, we just say format. Okay, what happens when I run this? That was a lot of code and a lot of thinking, a lot of thinking about Digimon. 73, there's a comma where there should not be a comma. Parts len, expected, you can convert usize. Used to, okay, it needs to be we need to convert it to a usize, and we can do that. Screw it, let's just do the dumb thing. If and else have incompatible types. That's fine, because we say okay. Oh wait, hold on, I can chain this, can't I? So let's maybe go okay or and actually, we don't even need this check, right? That's built into this option. Okay, result stir, so let's maybe say to string. I don't think we collected our map. We didn't. Okay, so we need to collect this into a vec. Okay. Method not found in vec result. Cannot be built from a string. This is a nightmare. Why collect 2x? This is a good point. I don't think I need 2 collects, right? I think I can probably just collect once. I can probably do this in one step. and collect should just make it work, right? That's a small error. Thank you, Future Highway. That was a very useful bit of input. That was so useful. This looks like I've just got a bit of syntax wrong. Likely around square brackets, so open. Too many close brackets. I'm getting hungry, so I'm hoping I can crack this soon. But I'm like, I've got the scent. I'm so close. Vex string cannot be built from an iterator over elements of type reference to reference of a string. So parts get. So because parts, so I'm guessing, let's maybe go, let's just be silly for a second. I could do this with a map as well. I just want to see like this. Which function should return result or option to accept? Oh, that's fine. Okay, let's map instead then. What was I saying? To string. This is really jank and is gonna turn to lifetime hell when I try and unpick all this string creation. What is unhappy? I don't want to let anything here. Okay, this function should return result or option to accept question mark. Where is there a question mark? I don't have a question mark, do I? Oh, it's in here. Ah, it's in here. Hmm. 75. Okay. Because this just needs to be... Oh no, what have I done? I'm just gonna see. Don't judge me. I've got mail. Don't judge me for doing this the janky way. Is this okay? God, I hate nested errors in... nested errors. Man. In these types. So if... Okay, this is getting there. There's so much copying on the heap being happening here that's really unnecessary. Result string. So this has to actually be an okay. Okay, warning, variant not used. Okay, here we go. Now what happens when I run it? We get something bad. We get something very bad. That's okay. So now we know what is here. Now we know we have an error. Let's maybe say format. And this is bad. Like, please don't do this. I'm just getting hungry and desperate. If I leave this in this state, it's only because... Only because I'm trying to work out what's going on. Okay. Now this is weird, right? Because you would think that this would fall back to... It would just fall back to okay. If the first character of the bit is not... So why do these... Pause P. Unknown token X. Okay, well we get something that's weirdly non-determined. I don't know what I changed to make that happen. Okay, I don't know what I changed to make that happen. Unknown token X. Well, this is better. I mean, this is more like what I expect, right? unknown token x on line 6, which is actually this line. Oh, that's another good point. Just quickly to go into main, every time I panic, I actually need to say I+1, because line numbers start at 0 here, but not in the real world. Okay, unknown token x. So when we evaluate this macro, we end up with an unknown token x, but we should know what x is. So why does this get lost? Why does it forget what x is? Why does it not know? Let's go even simpler here. This works. That's really good. This works. But now if I say foo x or y or something, it forgets what y is. Okay, let me try one other thing first, which is gonna be, what does it look like if it doesn't know what a So this looks the same, right, as not knowing. What? Why is there a colon here? Why have I picked up an extra character? That doesn't feel right, does it? That does not feel right. Okay. I've grabbed something extra. Also, maybe this needs to move into its own function. Maybe that would make it less fucking ugly. It's pretty ugly. Okay, I'm gonna engage my brain here. I'm thinking. P.2 string, that's good. Okay, I'm gonna do something silly. I'm gonna do something very silly. I'm gonna do a bit of debug printing, because sometimes that's just easy. I'm gonna go into our pretty printer. And every time we start to resolve, I'm just gonna say println just dump it out onto the screen. Let me see what's going on. Invalid digit found in string. I see what I've done. Because I'm not handling this properly. That's very funny, actually. This is this thing again. What am I actually doing here, right? Because this is just lines, all I'm doing is dumping the error into an actual string. Which, of course, when it fails to pass this digit, it just dumps this in. Okay. So let's say to do better error. Well, let's not even say better, let's say handle error here, right? Make this an actual error, not just part of the string. Make this a more complicated type. Make this do this thing as well with the collect, this outer bit. But I'm not going to do that right now. Not going to do that right now. Even though it's not that hard, I'm going to move this all into its own function at some point. The thing I am going to do is say, okay, let's say match parts get n as use size. So if it gets okay n, okay s, then we say okay s, and otherwise, actually maybe e, we just say okay p, you get whatever this part is back. Otherwise you just get the thing back itself. How does that sound? It's an option, sorry. lot of heap thrashing, a lot of heap thrashing. Now look, this just doesn't make sense, right? We shouldn't be, this error shouldn't be, oh, hold on, wait, whoa, 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 whoa. That was fine, I fixed the wrong bit. If this is an error, then we say, okay, P. That's better, that's more like it. Right? Because if this isn't a number, then we just want to keep going. If it is a number and something goes wrong, then that's a genuine error. But if it's not a number, we don't care. We can just pass that through, and then the next bit of the macro resolution will resolve it as a variable. This has been a bit messy. This has been a bit messy today. God, and there is a lot of stack thrashing. So ideally, I'm going to come in and rewrite some of this stuff to use string references more and actually have lifetimes on them and see if I can unpick this mess. Nice. Okay, now this works again. Now this works again. So let's go back to what this was before. And let's get rid of my gross debug printing. Nice. Except we want to make this arg1. I don't know, maybe it should be arg0, right? Maybe this does make more sense. Radix. I need a better test number so that I can see it's actually different. Awesome. This looks good. So this is a preprocessor. It lets us define substitution macros that, you know, take some arguments and do some things. That's really cool. And this is going to be the start of doing more things. So let's see if this can assemble the thing from the start of the stream, maybe. Progs. I'm going to have to make some changes. Def macro. That looks good. I'm going to have to change the labels because I decided that I should put the thing first. Okay, so what if I do this? What if I go ASM... progs fib panicked unknown token fib line 13. Yes, interesting. For now, I'm gonna do this. Even though it's wrong, the to pass thing is gonna be important. So we're just gonna see if this works for now, and it does. This seemingly does everything that the one at the start of the stream did. However, the thing it cannot do is reference a label that is defined in the future. Or a variable, right? I mean, if we want to say that sig exit is defined at the bottom of the file, who are we to say that that's not the correct place to do that, right? Who are we to say that you have to have this predefined? For labels, this is really, really freaking important. So we're going to have to add some kind of loose second pass that's able to resolve unresolved things. And usually you do that by keeping some kind of map, some kind of like list. You don't actually need to loop over everything a second time. So we'll do that. We'll make that nice and simple. But that is a problem for next time, because this has been a longer stream for me. I don't normally stream for this long, but it's been fun, right? We've written a thing that can do things. As usual, I will tag this and get it up on GitHub. What did I do here? But yeah, that's very cool. That's very cool that even though I have to hack it a little, I do have this working preprocessor, and it has this macro evaluation capability, even if the macros are a bit janky. And I'm going to get into this. I'm going to think about what this calling convention actually looks like, and don't look at it too hard. I haven't actually tested if any of this works, but now I have a tool that's going to allow me to write code much more easily, and that's very important. That's so important. So thank you very much for tuning in. It's been good to make a triumphant return to Twitch TV. I'm going to try and stream earlier in the day where possible, hopefully, because it's about lunchtime for me here. I'll hopefully try and get on close to 9 a.m. my time. I think that's better for Americans, and I know I have a lot of Americans watching. So thank you everyone who's tuned in and stopped by. It's been really good fun. Thank you to everyone who's continued to follow my Twitch channel even while I haven't been streaming. I can see there's a list of you, and it's fantastic. So good, so good. This is going to end up on YouTube somewhere. I'm hoping to make some dedicated YouTube videos, like non-live streams, but we'll see how we go with that. It's all good. It's all very exciting. Hopefully going to be doing a lot more of this. Thank you all again so much. I will see you all very, very soon.